Hello, in this short tutorial I will show you how to convert between primitive and conventional crystal cell structures representations using online application. The application is called XRDlicious and it was primarily developed for calculating online powder X-ray or neutron diffraction patterns, but it also includes this function. And besides the conversion, it will allow you to download the corresponding file either as a zip file or for DFT calculations with WASP as a POSCAR file, or for molecular dynamics calculations with LAMMPS as an LMP format. The application you can access through this link, or you can just simply write XRDlicious and it will also take you here. Okay, so let's illustrate it on an example. I will upload here my structure file, and it can be in various formats. I can upload a ZIF file or LMP file, POSCAR file, or also, for example, XSF file. And in my case, I will upload cubic beta titanium. And there is another option how I can add structures here, and it is through the implemented interface, search interface in Materials Project or AFLOW databases. And let's add one more structure by searching through the Materials Project database for this composition. And for instance, let's add this first one. So now that I added both structures, I can immediately see how they look like here. And the second one, beta titanium, like this, and it is in primitive cell representation. If I want to change the representation, I need to do it from this sidebar, so I can choose the conventional cell. You can see it was changed. Or I have three options for the primitive cells. Two are with a further lattice reduction, which can reduce the skewness of the cell, or I can choose the primitive cell with no further reduction. And if I want to download the structure, I can do it through this window here. So let's, for instance, download conventional cell for beta titanium, and if I want, I can download it already as a supercell. For example, let's download 2x2x2 supercell, and you can see how many atoms will be in this supercell. And let's download it as a format for WASP. I can also modify here if I want to have the output POSCAR file with fractional or gated Cartesian coordinates. And I will download it now. And for the second file, let's download it in the primitive cell representation with Niggli reduction, and let's do it in the LAMMPS format, where I can choose different options. So I can select the atomic style, which can be atomic, charge, or full. Then I can select which units I want to have in this LMP output file, and also if I want to have in this file atomic masses. And this let's download as 3x2x3 supercell. Other two options that I can select is either the ZIF file or XYZ file. And now, just to see that it was downloaded correctly, Let's visualize it in Ovito. So the first one is the primitive cell, 3 times 2 times 3 supercell. So you can see it's correct. And then the beta titanium, it is as a conventional cell with 2 times 2 times 2. So also you can see it was correctly created. Okay, so this is all, and I hope this feature will be useful to you, and thank you for your attention.